So in our activity today, we're going to compare men and women's in the 100-meter dash in the Olympics from 1928 to the year 2008. We're going to see if these are linear relationships, if they're proving at a constant rate of change, and then we're going to use this information to make a prediction in the future. And so let's go ahead and get our calculators out. And the first thing that I'm going to want to do is we're going to enter the information into our calculators. And so to do that, you're going to start with the stat button and you're going to edit a list. And so I've already entered information in here in list 1, 2, and 3, but this is what you should be doing here. For list 1, you're going to want to enter all of the years, starting with 1928 and going all the way down to 2008. And so that's what I have in list 1. And you can pause the video at some point to get caught up here. And then in list 2, if we work on this together and do the same thing, my calculator is going to be a little bit different than yours because I just made up information here. And you're going to want to put the actual women's gold medal times in list 2. So you would want to start with 12.2. and then 11.9, and then 11.5, 11.9, and list all of the women's gold medal times in list 2. And then go to list 3, and in list 3, you're going to want to put all of the men's gold medal winning times, starting with 10.8, and then 10.3, and 10.3, all the way down to 9.69 in 2008. One of the things you want to watch out for is that when you get finished, you should have the exact number of data points entered for all 3 lists. And so if you can see, when I scroll down to the bottom of my list here, you want to make sure that all of these points are entered the same amount of data points. And that's the information that we're going to enter. And if you're not there yet, go ahead and pause right now and then get all that information entered accurately, and then you can move forward. The second thing that we're going to do is we're going to turn on a function that's going to help us to find the correlation coefficient here in a little bit. And there's a catalog button above the 0, but you have to go second catalog. And then you want to scroll down to the D's. And we want to make sure that you have the diagnostic on. And so if you go to where it says diagnostic on and click or enter there, and then enter again, it'll make sure that the diagnostic is on, and that'll help us with the correlation coefficient. And we'll talk about that here in a little bit. After we turn the correlation coefficient on, and you have your information entered into your calculator, one of the things that we want to do is actually come up with a scatter plot. And so we're going to make a scatter plot here of everything so that we can actually see what we are working with. Okay, so what we're going to do now is, let me get out of this mode. So we want to make a scatter plot, and so our scatter plot, we're going to start by, if you go ahead and click the y equals, you want to make sure that everything's cleared out of your equations. Your plots are all turned off. Right now, if you press graph, you probably get something like this. If you have something there, then you want to go back to y equals and make sure that you have nothing on any of these equations. And so what we want to do is turn one of these plots on. And to do that, we're going to go second and then press the y equals. There's your stat plot button. And you can see all of the stat plots now are off. We want to turn number 1 on. So I'm going to click on number 1. I want to turn it on. I want it to be a scatter plot. There's other options that we have here, but I want it to be a scatter plot. I want my x values to come from list 1. I want my y values to come from list 2. Those are the defaults. And I want to mark each year, each gold medal Olympic winning time with an open circle or an open square. And so that is what will show up on the graph here in a little bit. But the other thing that I want to do is change my window. So if you click on the window button, our x values, which are our years, start at 1928. But I'm going to go ahead and start mine at 1924. And my maximum x value is 2008, but I'm going to go up to 2016. My scale is going to be, let's say, every 4 years. And my Y minimum, remember my Y values are my times. So my lowest time is 9.69. So I'm just going to go to 9.5. And I'm going to go all the way up to my slowest time is 12.2. So I'm just going to make that 12 point, let's say 4. And I'm going to count by 0.1s. That's the scale. So now when we press graph, what we have are my times for women. Now yours is going to be different because you actually have actual data that you put in there. It may not look as linear as what I have, what I just made up on my calculator. And this is the gold medal winning times for the women. We can do the same thing for the guys. If we go to second y equals, and the first plot is for the women, we're going to go to the second plot this time, which is going to be for the guys. And so I'm going to go to plot number 2. I'm going to turn it on. Again, I want a scatter plot. The X values come from list 1. And if you don't have the Y values coming from list 2, that would be second and 3. So you'd have to click on there, second, and then list 3. There's the yellow L3 there. And I'm going to mark the guys times with a plus sign. And so I'm going to move over here to a plus sign. I shouldn't have to change my window at all. And so now when I press graph, I have the guys times down here, and I have the girls times up here. And so what we want to do now is come up with a line of best fit for both the guys and the girls. And here's how we do that. And again, my line of best fit is going to be different than yours because you have the actual data in your calculator and mine is just made up. So to come up with a line of best fit for the girls, for the women's time, we're going to go back to the stat button. We're going to go over to calculate this time. We're going to calculate a linear regression line, which is number 4. So I'm going to press enter there. And I could just press enter and it would default to the list 1 and list 2 data that I have in my calculator. But the calculator now wants to know where is it going to get its information from. And we want the X values to come from list 1. So I'm going to type in list 1. And again, that's second L1 and then comma. The second thing that the calculator wants is where is it getting its Y values from. And so that's from list 2. And so I'm going to go after the comma, second list 2. Now I could press enter here, but what I want to do is put in another comma. And so that I don't have to retype this equation, it automatically goes in my equation for my graph. I'm going to go after the second comma, I'm going to go vars. It's a Y variable, so I'm going to move over to Y vars. It is a function, so I'm going to press enter. And I'm going to put it in Y sub 1. So because this is the women's, the X values are in list 1, the Y values, their times are in list 2. And I want it to be in equation Y sub 1. And now I'm going to press enter. And so when I press enter, you can see that here's my equation. The slope, that means the girls for mine are improving by negative 0.016 seconds every year. And the y-intercept's 43.7. And so I went back to make sure I had the correlation coefficient in there. If you did not get R squared and R, then you want to go back to your catalog, so second catalog, and turn the diagnostic back on. And so the correlation coefficient here of negative 0.97 means that for what I had in my calculator, there was a really strong relationship, linear relationship with the data. That means my prediction I can count on a lot more than if this number was closer to 0. The closer the correlation coefficient is to -1 or +1, the stronger that relationship is going to be. And so then we want to do the same thing here's my graph. So there's my women's times, there's the line of best fit for the women's times, and now I want to do the same thing for the guys' times. So I'm going to go back to stat, move over to calculate. Again, I want to move down to a linear regression line, only this time my X values are going to come from list 1, but my Y values are going to come from list 3. So I am going to put a comma in there. I want to put it in a function automatically. So I'm going to do that by going to vars and then move over to Y vars. And it is a function. except instead of y sub 1 this time, I want to put it in y sub 2. And I'm going to press enter there, and you can see there's my correlation coefficient for the guys. What I have in for my calculator for the guys is really strong. If I go to y equals, I have the girls' time in y sub 1. I have the guys' time in y sub 2. And you can see the other y values here I don't have anything in there for, just those two equations. If I go to graph them, I have the guys' line, the girls' line first, and then the guys' line. And then I can do several things to make some predictions. So if I want to go to the table of values for my equations, this is the way I would do that. I can start by going to second and go to table set. And I can start my table at any place. I'm going to start it in the year 2000. There's my X value. I'm going to have it go up by 4s. And now when I go to the second and the table, it's giving me two things. In the year 2000, this would be the guys' time, and this would be, or the girls' time, and this would be the guys' time, according to the equations that I have in my calculator. You can scroll down then and go to any year that you want. And so, like, I think it asked in 2052, what are your girls' times and what are your guys' times? According to what I have for my equations, the girls' times would be 10.26, and the guys' times would be 8.9. And so that's one way that you can make a prediction. You can also make a prediction by going to the vars again and move over to y vars. And if you press 1 for functions, I can go to the first y sub 1 function, and I can type in, let me try this again. Let me go back to clear the mode. And if I go do that again, vars, and then move over to y vars, and then press enter for the function y1. And now if I go and press the parentheses and I want to make a prediction for the women in the year 2052, I can then close those parentheses. Close those parentheses. I guess I got to do it on the calculator instead of my computer. And press enter. It will tell me what the prediction is for the women in the year 2052. And so there you have it. You can look at the graph. You can see if they're linear. You should know the correlation coefficients. You should be able to write in what the equations are and then make predictions for any given year. So hopefully this helped. If you need more clarification on this, you can go back and rewind it, or we can ask tomorrow in school.